Welcome back to our series on agents in production. I'm Sam, I'm a tech lead here at Fuzzy Labs.
And I'm Yaz, I'm an MLOps engineer here at Fuzzy Labs.
Great, so let's start simple. Can you explain to me what we mean by an agent in production?
So an agent in production simply means an autonomous agent that's been deployed in a production system that's serving either real users or is interacting with real systems.
So Anthropic have made it really easy to get up and running with agents. What risks are there with them?
Well, firstly, I think it's great that Anthropic have done this, lowering the barrier of entry for developers to use agents. I think there's a lot of risks with this. Firstly, developers, they just want to get the work done. They want their workflow as efficient as possible. But with this, they may give a lot of agency to the agents. They may allow the agents to run dangerous code for them or delete files in their own system. So simply put it, the more agency you give an agent, the more risks that come with that.
So there's a trade-off between that capability and that risk. But where would you start with trying to find that?
Well, it's difficult to balance the risk and rewards. Firstly, I think you need to do some sort of threat modeling, analyze the failure modes where an agent can go wrong in your production system, and analyze the worst case scenario. So things like reputational damage, financial loss, even malicious actors coming in and hijacking your production systems. Start with the worst case scenario and build from there. If you can balance the worst case scenario with the rewards that you'd get from deploying an agent in production to increase revenue or whatever you may use it in a business case scenario, then you can start from there and now you have your foundations.
So building on that worst case scenario, could you give me an example of where it could go? A specific example from if you put a specific type of agent into production, what could actually go wrong? Like how bad could it actually be?
So it really depends on your use case, but for the most part, in a software engineering type workflow, it will bring your production systems down. It will cause downtime for your applications, and it will prevent users from being able to use your application, purchase products, which would cause financial loss. And that's one of the worst cases. Other cases could be malicious actors hijacking your agents to extract data, personal data, and compromise the data of users, which also you can incur fines on top of that. So there's a lot of worst case scenarios here.
And coming back to that kind of drawing the line at the right place, the industry of which your application is running in also really helps to define that. I guess if healthcare application, for example, or banking, if these systems go down, it's not just a small problem, it's a real problem that affects genuine people. So I think it's an interesting point of, right, it's not always the same story of where to draw the line.
Exactly. And it all depends on what your use case is. If your use case is high risk, such as healthcare, then you may need to reevaluate your agents in this use case. But if it's something simple, just like reading logs from a database or your application, then an agent seems like a good idea.
So when it comes to permissions, can you just talk me through a little bit of how you approach permissions for our SRE agent?
Yeah, so you'd start with the principle of least privilege. So an agent by default should have no permissions to do anything. And you should assess what should your agent need access to. In an SRE agent, well, we only need a few things. We need to be able to read logs from an application running in a deployed environment, such as a cloud environment like Kubernetes in AWS. It needs to be able to read code from your code base to diagnose the bugs. And it needs to be able to post a message to Slack to interact or inform the developers that there's a bug here and inform them what the bug is. So when it comes to permissions, you need to look at the APIs. So for example, with GitHub, you should only be able to read code from an individual code base. You shouldn't be able to open pull requests onto random open source code bases, because then you can exfiltrate data, and then attackers could come in and read those logs and read that data and steal your data. So start with what does your agent need access to, and then build up from there. And we do the same thing with Kubernetes interactions. We do the same thing with Slack. We only give permissions to the agent for what it needs to do. So for example, with Slack, it should only be able to post a Slack message to one single channel. It can't interact with other Slack channels, just one single channel.
So where are you setting these permissions then? Are these permissions being set directly inside of the MCP server, or are these being set when you're creating the API token that it's using, for example?
So these individual permissions are being set on the API tokens. This is just regular development practice. Principle of least privilege. It's something every developer should know, and we apply it in the same way to our SRE agent. With MCP Tools, there's an additional layer of permissions that we can add on top of this.
So digging a little bit deeper into MCP tools, we know there are some official MCP tools out there, but there are lots and lots of unofficial third-party MCP servers, which first glance seem like really good, useful tools. Should us as developers trust them straight out of the box, or do we need to be quite cautious when we start downloading these servers?
Yeah, so should you trust them? Absolutely not. Don't trust these tools. They come from completely random users. You don't know their intention. They could just be trying to benefit the community as a whole and just trying to build something cool out there. But you can't trust these for sure. So stick to the official ones. For example, GitHub have their own MCP server, and then you should be using that one if you're interacting with GitHub. But I see you can't use an official one. What you should do is stick to reputable repos. So stick to GitHub MCP servers that have high stars. So this is one way you can ensure that you're using a sort of reputable MCP server, but obviously it's not foolproof. So what you should do next is you should examine the code underlying in these MCP servers. So look at the tool descriptions, look at the APIs these MCP servers interact with. You should check these tool descriptions to make sure that the tool lines up with the description. So there is a hidden prompt injection, for example, that your LLM's eventually going to read. And you should look at the APIs. Do they match the description of the tools? So for example, one tool could be named read a file, but the API is actually writing, to a code base. So you need to make sure these line up. And you need to ensure you do this for MCP servers that you do not trust.
So there's this idea of MCP scanners. In the same way we have virus scanners, are there any tools where a developer can actually scan these MCP tools before downloading them, or anything that they can use to try and, rather than just GitHub stars, it's an actual tool that enables them to get a little bit more trust when trying to use one of these third-party MCPs?
Yeah, so as of yet, there hasn't been an established tool to scan MCP servers. That's something I'd like to see in the community, something similar to Python dependency scanners where you can scan for vulnerabilities in your Python packages. But it would be really nice to see something equivalent but for MCP servers, which you can scan MCP servers before you deploy them, and you can integrate them in your own CI/CD pipelines whenever you use them.
So if you've got one of these tools in development, please do reach out. We'd love to hear from you. So you limited the agent's capabilities to just 5 tools. Tell me about why you did that.
Yeah, so there's 2 reasons why we did this. Firstly, it's just more efficient for the agent to know which tool to go after. And it's much easier to work with 5 tools rather than 70 odd tools, which is what we'd normally have with all the MCP servers that we have in the SRE agent. But we limit them to only 5 tools such that the agent, the LLM, can easily decide which tool to use and when. The second one is the security angle. So we don't want the agent to use tools outside of its use case. So it should only be able to read logs, read files, post messages to Slack, list Kubernetes nodes, for example. It should not be able to delete Kubernetes pods. So we need to restrict those tools. And if we can restrict the tools from 70 down to 5, we can be a lot more certain that our agent will be able to perform in a secure manner as possible.
So let's dive into threat modeling a little bit. What is threat modeling?
So threat modeling is a structured approach which you can use to identify, analyze, and mitigate vulnerabilities in your production systems before they can be exploited. And this is a term in cybersecurity. It's a pretty old term, but we can use this again to analyze the threats that could be exploited in our SRE agent.
So what sort of threats could our SRE agent actually experience? What have you been modeling?
So one of them is the attack vector of these untrusted MCP servers. One of them is whether a malicious user could upload MCP servers on the internet and then we inadvertently downloaded it and used it with our SRE agent, and it contains bad descriptions that contain prompt injections, which cause the LLM to do unintended stuff that the attacker originally intended to, but that we don't. So that's one angle, that's the MCP angle. Another angle is whether or not the SRE agent can interact with the user directly. And with our SRE agent, it doesn't interact directly with the user, but it reads logs from the application. And these applications, logs can contain data from the user, for example, user agent headers in API calls, or it can contain user data from inputs in a submission form. And a malicious user can, let's say, if they know that this application is being monitored by an SRE agent, they can add their own prompt injections within these user agent headers or the submission forms and attack our own systems. So those are the two main avenues of attack, and there's different ways of exploiting our LLM, but if we can defend against those, then we should be confident that we can prevent these types of threats.
So if I'm watching this video, I might be starting to get a little bit concerned that there's too many threats out there. I shouldn't be trying to deploy an agent, MCP agents. That's not what we're trying to get across in this video. So can you just actually talk us through a bit of how we can mitigate against these threats and actually be able to deploy these models?
Yeah, there are many ways to deploy these models safely. There are a lot of threats, but there are also a lot of defenses. One of these defenses, like I said, is just sticking to official MCP servers. Don't use anything untrusted. Stick to reputable servers, read the tool descriptions, look at the APIs being used, and that's the MCP angle. The other angle is whether your agent interacts with input data from a user. And to sanitize or to prevent any misuse from the input data that a malicious user can send to your LLM, you can use things like guardrails, or you can sanitize your input data. And guardrails are pretty handy because they can be used to detect different types of prompt injections like jailbreaks, and you can use these to, for example, in the context of an SRE agent, to read the logs and detect whether prompt injections exist within these logs. And you can use input guardrails, as I mentioned, to detect prompt injections, or you can use output guardrails to check that, for example, you're not leaking any data in the outputs of your LLM. And you can put these both on either side of your LLM. And on top of this, there are many other defenses that you can use. The landscape defenses is increasing. So don't be scared to deploy these agents. Just make sure you do them securely.
Sounds like good advice to me. Well, thanks for that, Yaz. That's been really interesting. If you'd like to give it a go with our SRE agent we've built, then head over to our GitHub. Give us a star if you feel like you like it. And then we've got a whole series of blogs on this. So please go over to our website, have a look at all of the blogs, which goes into a lot of detail on all the different things that we've covered in this series. Thanks.
Thank you.